Now going to question 22, we have a square inscribed in a circle. So let's go ahead and imagine the circle, and then let's go ahead and imagine a square inside that circle. Now, we're being told about the radius. So the best way to relate the radius of this circle to the square is to go diagonally. So this diagonal radius here has a length of 20 root 2 over 2. Now, the way to relate that radius to the square is through right triangles. Because if that radius is 20 root 2 over 2, then this diameter is 20 root 2 over 2 plus 20 root 2 over 2, which mathematically is 40 root 2 over 2, and that simplifies to simply 20 root 2. So we now know that the hypotenuse of this right triangle is 20 root 2 without the denominator. Now that hypotenuse, the diameter of the circle, that is part of an isosceles triangle. Because what is a square after all? It's a rectangular shape where all four sides are the same length. And so by that token, this green triangle right here is an isosceles triangle. And why do we care? Because any isosceles right triangle is automatically a 45-45-90 triangle. And you should know that ratio by heart, even though it's given to you on the formula sheet. The ratio for the 45-45-90 triangle is x, x, x root 2. Now, by the way, you can also work this using Pythagorean theorem, but special triangles, the 45-45-90 triangle, is definitely quicker in this situation. So the same diameter of the circle, which is also the hypotenuse of the right triangle, we already knew from the beginning that it had a length of 20 root 2, but in terms of that right triangle, in terms of that 45-45-90 triangle, it's also x root 2. So we're finding out that the x of the 45-45-90 triangle is 20. And that tells us that these two sides are also 20. And so now we have the answer to the question. What is the side length of the square? We just saw that it was 20. So the answer here is A.